Okay, so evaluating logarithms on a calculator, I already showed you how to do this. Make sure you always go the log of your argument divided by your log of your exponent, or log of your base, sorry. So log of your argument divided by the log of your base. Every time, if your base is 10, you could just type in log of your argument, okay? So for example, log of 1,000 base 10, you just type in log of 1,000 in your calculator. Because if it's base 10, that's your normal log in your calculator. If the base is anything else, you're going to have to divide by the log of that base. Right, Lucas? Yep, this is just review. Okay, so to evaluate log of 1,000 by converting to exponential form, we did this last class. Am I on the right page?
No.
Oh yeah, this is lesson. Oh, because we still have 3 pages left of this lesson. I see. Okay, so if I have log of 1,000, what is my base going to be here? If there's no base there, what do I assume it is? 10. It's always 10 if there's nothing there. Put your phone away, or else I gotta take it away. Jeez Louise. Okay, so if I have log of 1,000 base 10, if you're going to convert this to exponentially, set it to or equal to a variable. Okay, so we did this yesterday. Now I can put this exponential. My base stays the same, so how do I change this to exponential? Yep, so we 10 to the x, and then we change 1,000 to a base 10, so it'll be 10 cubed. So your x is equal to? 3. Okay. And then, like I said, also yesterday, you could do this all on your calculator. It's a lot faster. So if it's a base 10, all you have to do is go log of 1,000.
3.
Enter, and it'll be 3. Okay.
But if it had a base?
If it had a base, then you would go log of 1,000 divided by log of your base. Okay. We already did this yesterday, did we not?
Yeah.
Why am I doing it again?
That's why I said what I did.
Why?
I don't have anything written on it. No, I didn't either, just the bottom part.
Oh, okay. Okay, so just turn the page because we already did all that yesterday. So try to evaluate log of 50 base 5. What problem do you encounter? So try this in your calculator first, and then we'll see where that goes. Is it decimal?
Yeah, it's a decimal.
Okay, so let's figure out why it's a decimal. So log of 50 base 5, set it equal to x, and let's try to solve this exponentially. Yep, 5 to the x equals 50.
Oh.
Yeah, you can't change 50 into base 5, okay? So this is the reason why this won't work.
So if you put it in your calculator and you get a decimal number,
Then that'll be your answer. That'll be your value, yeah. So if you can't do it exponentially, then your calculator will give you that answer, okay? Okay, so I'm not too worried about this to find the alternative because you know that 5 squared is 25, 5 cubed is 125. You know the answer is going to be between 2 and 3. I'll just write it. 5 squared equals 25. 5 cubed equals 125. So it's going to be between 2 and 3 because those are your exponents. But you could just put this in your calculator, and then that would be so much easier than, like on the diploma, you have your calculator the entire time. I'm not going to worry too much about this, okay? Okay, evaluate log 25 base 5, converting to exponential form. We've done this enough. I'm not going to worry about that again, okay? So, form which can be evaluated using a calculator. What? This one and this one?
yeah. The log
You tell me. They should be. Tell you the truth.
You tell me, just in the other.
Log of 25 divided by log of 5. 2. Natural log of 25 divided by natural log of 5. That's 2. Yeah, so it doesn't matter if you do natural log or log if you're dividing, okay? The time it will matter is if your bases are different. So if there's no base, so if it says, if it's just log, for example, log of 100, you have to put in log of 100. You can't go natural log of 100. Because if a logarithm, it assumes base 10, natural log assumes base e. Okay, so that's the only difference.
Oh, okay, yeah. I guess, yeah.
Okay. So we've done all of this. You could just put this in your calculator. Do you mind if we skip it?
No, yeah.
Everyone's okay with that? Okay. So this is just saying, to put this in your calculator, you always go log of your argument divided by log of your base, or natural log of your argument divided by natural log of your base, okay? Either one of those, put it in your calculator, it'll give you the value of that logarithm. You can also do something like this, converting to base 10. Okay, for example, log of 1024 base 4 can be evaluated by converting to base 10, so just writing it like that, or to base 2. We're not going to worry about this kind of set right now, okay? That might just confuse you.
Yeah.
So evaluate by changing the base round to the nearest hundredth. I don't know if I want, because you guys can just evaluate these in your calculator, right?
Yeah.
Right? Would that confuse you if you change the base? How would you do B? So B in your calculator, we could just do these in our calculator. So I'll show you how to do B. So I go 3 times, and then I have, guys, log of 1 over 1,000 divided by, guys, log of 2. I think this is why. Yeah, with that 3 there. So you just go 3, you put the 3 in the front, multiply, put everything else in brackets. You don't necessarily have to put everything else in brackets, it just keeps it separated. So if I didn't put this bracket here and this bracket here, it still would have got the same answer. Just because it's multiplication, okay? So your answer would be, if it's saying round to the nearest hundredth, negative 29.90 would be your answer here. Okay, are there any questions as how to do this? You guys okay with this? This one, for C, you would figure out what the value is for your logarithm. So I'll just do C in my calculator for you. So you find the value of your logarithm, so go log of 216 divided by log of 6, enter, so it'd be 3, and then you would use this as your exponent. So then it would be 6 to exponent 3, enter, so your answer here is 216. This is for C. So if you have something like that, find out the value of your logarithm, and then that is your exponent for your base.
Okay, I have a question, because it seemed like the one we did yesterday, what that was like that, also equaled out to the number that was in the exponent?
No. Not always, okay? So the one we did yesterday, we changed this to exponential form to find the value, and then we did it so there's a lot more steps, okay?
Wait, so 216.
So this would be log of 216 divided by log of 6, and then you press enter. That value is your exponent for 6.
Oh.
Does that make sense?
Yeah.
You guys have any questions?
And then if it equals like whatever that number is, like 216, then you know how you went 6 to the power of 3 and it was 216.
Yeah, so 6 to the exponent of 3 is 216. Yeah, because 3 was my value for my logarithm. And then 6 to the exponent of 3 is 216.
So that's all you would have to do for.
Yep, that's to answer that question. Do you want me to put D in my calculator to show you how you would do that?
Yeah. Dilly, grow up.
Okay, so the exact same thing. So you go log of your argument divided by log of your base. So go log, my argument is the square root of 1 over 1024. So that's exactly what we're putting in, the square root of 1 over 1024. The biggest thing here is to watch your bracket. So bracket, this will close my square root.
Oh, inside of
And another bracket will close that one.
shut.
Okay? And then divide it by log of 2. Okay. Okay, are there any questions with how to put these into your calculators? The first one, go log of your argument divided by log of your base. Okay, so let's do this last one really quick, and then it'll show you how to use your graph. So there are different ways how to do this as well. Okay, consider the function f of x equals log of x base 7. So let's graph this. So y equals, again, to put this into your calculator, you have to go log of your argument divided by log of your base. So log of x divided by log of 7. Is everyone here? I'm just going to go to the standard window because it should work. So zoom 6 is standard. And then I can zoom in now that I see that. So my y can be a lot less and my negative x can be less. So my x min, I'm going to start at 0 and go up to 10. That'll work. It should work. My y min, I'm just going to go negative 5 and 5. Just to make it bigger for us. I could even with smaller y, but that's fine. Does everyone have this?
You go back to.
Yep. Get it? Okay, so sketch the graph. I'm just going to copy mine over because I can do that.
Cheater, pumpkin.
You're just jealous that you can't do that on your notebook.
Hope that I can. One day that'll happen. You don't even have to write stuff. It's like bring your fingers in.
You betcha. Okay, so use a calculator to solve these equations. So if I have f of x equals log of x base 7, my f of x is going to be my y, right? So if I give you a value, so log of x base 7 equals 5, is 5 going to be the y or going to be the x?
That's a y.
Y. So I'm looking for my x. So my y, if I give you a y, how do you graph this in your calculator and find it? Yeah, so y2 equals 5. Going to tell you right now that you probably are going to have to change your windows to have a larger x value. Yeah. So y2, 5 graph, you're going to see them both, but you're not going to see the intersect. You have to make your x max a lot bigger.
So like 500.
Yeah, you could try 500. So this is kind of where you have to guess and test, or you can go zoom. I wonder if zoom fit would work. I'm going to try that. No. Okay, I'm just going to change my x max. I'll try 1,000. So you just have to keep changing it until you see that intersection. No, we're getting closer though. We got about halfway, so I'm going to try 2,000 here. Oh. 2,500? That'll work?
No, I didn't
Are you getting closer? We're getting closer.
Okay, so I think it might be 10,000. Oh my god, I need to. Yeah, it's not 10,000. It's about
15,000?
15,000. Please, mother. Oh. Mine, I think mine would work. Yeah, mine will click that.
Oh, I'm just gonna make it bigger. I'm just gonna make 20,000 and see.
Grow up.
Okay, that should work.
Yeah.
You guys still with me? Do y'all have this on your graph? Good? Okay, so if I have two graphs intersecting, how do I find the value of x? Second trace intersect. So if you get a value, then you know they've intersected. If you don't get a value, you might have to change your windows. Does everyone get this?
Yeah.
Good.
So where do we So your x equals 16,807?
Yep, so 16,000, yeah, 16,807. No, 60,807. Okay, this next one, you can see how they changed our f of x. They changed your f of x, but you can see how you can kind of manipulate this formula to get f of x there. So first off, let's try, so pretend log of x base 7 is x. Can you isolate it? Yeah, so I here add 9 to both sides. So I have 9 equals 3 log of x base 7. Is everyone okay with this step so far? Okay, so now that I have 3 times my logarithm, divide by 3. So 9 divided by 3. So 3 equals log of x base 7. So now can you solve this question and solve for x? So solve for x when y equals what? So y2 equals 3. So near y2 now, we can get rid of the 5 and just put 3. Graph it. Does yours work? If one of your guys doesn't work, just let me know, okay? Because we can figure this out. Sorry? Who's saying this? I don't know who's talking. Sorry. Shay? No. Okay, go to your y equals. Is this what you have in your y equals? Log of, it goes log bracket x bracket divided by log bracket 7 bracket. Yeah, no worries. Okay, while we're waiting for this, you guys can start on number 7. Yep. They can work on number 7 right now, Shay. We'll get you figured out right now. So you guys start on number 7.
Number 7 where?
On the assignment.
On the apps. I already did number 7. Oh.
We'll do number 8 then.
Oh. Darn.
Oh, what?
It's so weak.
Kaylin, do you have her calculator? Is that what you're trying to figure it out?
Yeah, I think my Windows just really messed up.
Okay, this is my window if this helps. My y, I'll just put this as 0.
I'm sure that's why there's nothing there. That's what they expect from number 2. Do it.
Is it not working? Okay, we're going to reset your calculator because sometimes they act really stupid. So go second, so clear out of this, go to your normal mode, go second plus, and number 7 says reset, and you're going to reset all your RAM, so press 1 or just press enter. Did it clear? So if you press enter, you just go down to reset. So you just go down and then press enter. Does that make sense? Does it say cleared? Is that what it says?
It says RAM cleared and then a thing at the bottom is square.
Okay, good. So your RAM is cleared. Does it look like this? Well, it said RAM cleared. That's the biggest thing we need. So let's press enter. Okay, so now go into your y equals. So we're going to start over. So go log. Okay, so go y equals. Are you there? And go log of x. Close your bracket. Divided by log of 7. Close your bracket. Let me know when you're there. Okay, go to window. Our x min, we can just make 0. X max, we had 20,000. And then 2,000 for your scale. Y min, we can just go -2. That should work. Y max, I go 5. Yeah. Okay, and then should look like this. Did it work? Is it pretty close? Okay, so let's see if it works. So we're going to put 3 into our y2. So go back to your y equals. And to your y2 equals, just put 3. And when you graph that, it should look like that. No? Yes? Just put it under your camera. So you'll have to take control of the desktop and then show me your document camera. Yep. Okay, so press second trace. And then you're going to find the intersect, so number 5. And then you can just go enter, enter, and enter. 3,547, is that what you guys got? 340. Did you get 3,547? Is that what you guys got for this one? Yes?
Yeah.
For C part 2. that what you got or no? Page 265, C, class example 8, C, part 2. You get. Yeah. Is that what you guys got too, or did you get this? Okay, let me try on my graphic. The one we just did. Oh, you didn't finish it? Okay, go to y equals, Shay. Let me see what you got. Oh, because you have log of x times log of 7. You don't have that division sign there. So between the x, yeah, so go second delete will be insert. So press second delete. And then press divide. And now graph that and see if that works. There we go. And then so go second trace, see if you get 343. Second trace of number 5, the intersect, enter, enter, enter. Yeah, 343. There we go. We figured it out. Okay, so the biggest thing, Shay, go when you are graphing a logarithm, it's always log of your argument, so that x was our argument there, divided by log of your base. Okay, so I'll share my desktop and I'll show you. So I'll show a different example. For this one, so for class example 7, to put this in your calculator, you go log of 1024 divided by log of 4. Okay, so that every single time it's not going to change. Log of your argument divided by log of your base. It depends what they're asking you. So if it says graph it like in number 8, you're going to put this in your y equals. If you're just going to find the value like in number 7, so if it's a question like number 7, I'm just going to exit out of this and just put it right in your normal screen. So I would go log of 1024 divided by log of 4. Enter. 5. Does that make sense? So if they're just telling you to evaluate the logarithm, yeah. So just when you're evaluating logarithm, you could just put this right into your normal screen. As soon as it says graph, that's when you put in your y1. Okay, so we're going to start the next lesson. Shay, if it's really confusing, please stop me and I will show you how to put in your calculator, okay? Okay, so lesson 4, I'll try to get through this one. If I don't, it's not a huge deal, but I do want you guys to work on both of these lessons, okay? So lesson 4, now we're going to do some practice and we're going to see what some of the laws are, okay? Because there are some rules, just like exponential equations, there are some rules when you're adding, subtracting, multiplying, dividing logarithms, okay? So evaluate the following. To evaluate log of 16 base 2 plus log of 8 base 2, you can just put this on your calculator. Okay, so log of 16 base 2, log of 16 divided by log of 2. Enter. It's 4. You can put this on your calculator by doing it this way just so we can show at the end. Log of 8. divided by log of 2. Enter. It's 3. So 4 plus 3 is going to be 7.
And then put that all in.
Okay. So put into your calculator the next one. You would go log of, and now we have 16 times 8, so you can just go 16 times 8 right in here, divided by log of 2. Does everyone understand why I did this?
Yes.
Because in part A, or A part 2, 16 times 8 is in brackets, so you want 16 times 8 in those brackets in your logarithm, okay? You should get 7. Does everyone get 7? Do you see anything similar here? So look at A part 1, part 2. So log of 16 base 2 plus log of 8 base 2 is equal to 7. Log of 16 times 8 base 2 is equal to 7. Look at your arguments. So you have 16 and 8, and you have 16 times 8. Okay? So in part A, what can we say? Yeah. So W with the line above it just means with, guys. W with the line above means with, same base. You can just multiply the arguments. I'm just saying the value of log of 16 times 8 base 2 is equal to 7. So when you add logarithms with the same base, it's the same as multiplying the arguments. Does that make sense? If you could put it in better words if you want. So that's just saying like this. So if I'm adding two logarithms with the same base, I can just do the same, multiply my arguments, and then keep that base the same, okay? If you put B in your calculator, you'll get the same, well, not the same answer, but it'll prove it again. So I'm going to put this all into my calculator all at once, okay? So I'm going to go log of 27 base 3. So log of 27 divided by log of 3 plus log of 3 base 3. So log of 3 divided by log of 3. Enter. Yep, your answer is 4. Second part is log of 27 times 3 divided by log of 3. You got 4 again. I just put these two into my calculator right here.
Why are you dividing
Log of your argument divided by log of your base is how you evaluate a logarithm in your calculator.
Oh, yeah.
And then I'm adding log of my argument divided by log of my base. Second one, log of my argument. My argument is 27 times 3 divided by log of 3 is log of my base. Okay? Is everyone okay with this rule? So if I'm ever adding two logarithms, they have the same base, I can just put it all into one logarithm, multiplying the base. Or multiply the argument, sorry. Shay, are you keeping up in your calculator? Is it making sense? Okay, so this is your product law. Let's try the quotient law. See if this makes sense. Okay, log of 16 base 2. So log of 16 divided by log of 2. 2. Enter, so I have 4. Log of 8 base 2. Log of 8 divided by log of 2. Enter, 3. So it'll be 4 minus 3, which is You could put it all on your calculator if you wanted to. Yeah. And then I'm going to go log of 16 divided by 8, which is just what? 16 divided by 8 is just 2. You could have put 2 in that as well. Divided by log of 2. And this is going to be 1. Okay, you guys tell me the answer of part B. So go log of 27 divided by log of 3, subtract log of 3 divided by log of 3. Give me an answer. And then go log of 27 divided by 3 divided by log of 3. Yes, it should be. Aren't you just smarty pants?
And then I'm gonna guess that the second one is also 2.
Well, I'm just showing you. Did you guys get 2? Michaela, did you get 2? Yeah, everyone in Edgerton, did you get 2? Good. So what's my quotient law? What's my quotient law? Yeah, it's as close as it's the same as the top one except the opposite. Okay. So when you're subtracting, logs with same base, all you do is divide arguments. So right here is probably a good thing to highlight, star, memorize, know this. Any questions so far?
Pretty easy. You just add the subtraction sign or addition sign between it.
Yep. How far up? This far? Holy smokes, this is the whole page. Forgot to write down the answers. You were just sitting there on your phone probably, weren't you?
No.
Ooh. Did you get it? Okay, so let's try these. Am I going too fast or are you guys doing okay? No problem. Okay, biggest thing, are the bases the same? So look in part A, are the bases the same? Yes, what is my base? 2. So I can rewrite this as, so I have the same base, I'm subtracting my logarithms, what should I do to my arguments? If I'm subtracting my logarithms, I divide my arguments, yeah. So I go log, my base is still 2, and then it's always the logarithm on the right, or on the left-hand side, divided by the logarithm on the right. But you can also simplify this. So log, what's 12 divided by 3? So you can also write this as log of 4 base 2. Yes, I'm pretending I didn't. Okay, so log of 4 base 2, what is this going to be equal to? 2. Okay, this next one, go left to right, okay? So if I'm adding 2 logarithms with the same base, what do I do to the arguments? Yep. I'm just going to multiply them right off the bat. What's 9 times 8? 72. And then I still have to subtract log of 2 base 6. I'll put this in brackets too. So we still have the same base. When I'm subtracting 2 logarithms, what do I do to the arguments? So what's 72 divided by 2? Can you put this into your calculator really quick?
You want? You really could.
What is this value?
60.
No, it shouldn't be 6.
It's 2.
It's 2. 6,
Kill it.
6 squared is 6.
If you think you're right, now I'm definitely right to you. Never have I ever. Really? We play that game this time?
No, we're not. Are there any questions with class example number 1? You guys got this? Good.
Holy damn org. This is actually not that long.
Okay. Use the laws of logs to write log of 10 base x plus log of 75 base x minus log of 2 base x plus log of 3 base x. The biggest thing, med math. Knowing bed math, what should we do first here?
Brackets.
The brackets. Okay, so
Oh, that's fine.
log of 2 base x plus log of 3 base x, what should I do here? They're being added together. Yep. So what will my argument be? You have it right in front of your face. What's 2 times 3, guys?
6.
There we go.
Why do we always have to?
I somehow don't believe that sometimes you want to be close.
Yeah.
Okay, so now that I have no more brackets, I have addition and subtraction, so now you just go left to right, okay? So I have now this right here, so this is what I did first. This is what I do second, so I'm adding 2 logarithms at the same base. What is my new argument? 10 times 75. Did you just put that in your calculator?
Dude, I'm sorry, I'm stupid, okay? That's okay. Just so I take a dash 2. I've always done a dash 2. I still use my calculator for Plus 2 plus 2.
Okay, so guys, focus. What's my next step here? I have 2 logs being subtracted, same base.
Okay, I have a question. Why don't
Yeah.
we just all do it as one if they all had the same base?
Bed mess. You could have done it all together here, so you could go that times that divided by that if you wanted to.
Yeah, that's probably.
If you want to do that, I'm just showing my work, so if you're studying on an exam, you'll know what steps I did. Okay? What is 750 divided by 6?
I'm going to put in my 125.
Is this what everyone else got? Does everyone agree? Does anyone have any questions with how we got this answer?
No, not.
You're good? Okay, so now it says evaluate if x equals 5. So all I want to do is substitute 5 into my x. So log. Oh, sorry, Shay, you have a question? For your argument for 125. 125 divided by 6, it should be 750, sorry, divided by 6, it should be an even 125. No, did you put in your calculator wrong? You're not stupid. Okay, so just be careful with your calculator, make sure. The biggest thing on an exam is just slow down and double check whatever you're putting in your calculator. So if I'm going but if that was the case, Shay, it would probably tell you what to round to. If it doesn't, I would round to the nearest hundredth. Log of 125 base 5, what is this value? 3. Good.
Have a shot in the dark. I think it's 3.
Good show. Okay. I have log of x base 2 plus log of 2x base 2 minus log of x squared base 2. I want to see what it's equivalent to. Okay, so I have all of this. There's no brackets. I'm just going to go left to right. So if I'm adding two logarithms, I multiply my arguments. So this would be log base 2, x times 2x.
What? 2x squared? X squared.
Yeah, x times 2x is 2x squared. And I still want to subtract log of x squared base 2. Okay. Okay, when I'm subtracting two logarithms, what I do to my arguments? Divide. So what is 2x squared divided by x squared?
2.
2. Is that Logan? Oh. Jeez, remember your lunch kit for once in your life. Okay, so log of 2x squared base 2 minus log of x squared base 2 is equal to log of 2 base 2. Does everyone agree with that?
Because you divided that by x.
2x squared divided by x squared. You got that? Okay, if I ever have the argument and the base the same, what is this going to be equal to? What is my answer? Don't even. No. Okay, are there any questions, guys?
No, that's pretty good.
I'll scroll up a little bit. Everyone's okay? Okay, we're going to do class example 4, and then we will have a work period. Well, a work 25 minutes. So I have 3 log of p base 2 minus 3 log of q base 2 if p divided by q equals 8. The biggest thing here, you see how they both have this 3 in front? So they both have a 3 of a coefficient. Does everyone see that? We can factor the 3 out, okay? So there's a good reason why we did rational numbers first, because we learned how to factor. So let's factor it out. So if we factor the 3 in front, I have log of p base 2 minus log of q base 2. So all I did was factor my 3 out. So everyone okay with this step? So now I have it's just how I write my q's, sorry. So I have 3. When I am subtracting two logarithms, what do I do to the arguments? Yeah. So it would be p divided by q. Is everyone okay with me so far? Okay. If they give you p divided by q is equal to 8, we could put 8 into here. So this right here will go into this right here, okay? So this is 3 times, I have log of 8 base 2. How's that step? Is that okay? All I'm doing is substituting p divided by q equals 8 into. So now we can evaluate log of 8 base 2. Yep. So it would be 3 times, should be 3. Yeah. Well, 3 times. Did everyone get this? Yeah. Okay, there will probably be questions like this on your diploma because they like to, not necessarily trick you, but they like to ask really in-depth questions, okay? So if you can understand this and you've got this case, you're probably going to do okay in this section on the exam, okay? So for the rest of class today, we're going to be working on questions 1 to 6 here. You can work on the rest of the last assignment. You shouldn't have too much left to go on that last assignment, and then work on 1 to 6 here. The last 5 or so minutes of class, I'm going to fax over some questions to do, or that one question exit slip, okay? Just to make sure you know. I'll have 2 different questions, so you'll just do the different ones than the person you're sitting beside.